Franco?
And Majid, I invited Majid
Good.
to come back too. So he's Majid is joining us.
Okay, well, welcome to the June 4th, 2024 session of TAPR and HamSCI technical session. We're generalizing the name, and I'm going to plan on using that from now on. My name is Dave, KV0S. I've been watching the radios. I uh, upgraded my loop antenna. It had been 5 years since I put it up, so there was a little bit of uh, antenna rash, and so I just renewed it and put it back up. So that was a big thing for me this week. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Steve. Last week I was in Boulder, Colorado. I took four students with me, and I took Mary Lou West with me as well. And we were there for the NASA Living with the Star Focused Science Teams meeting. And what we were doing was the object of this project is to look at the differences between what's going on in the northern hemisphere and what's going on in the southern hemisphere. And actually, and Hyomin is there too because he's actually a team lead. So we were all there together, and my students and we were focusing on medium scale traveling ionospheric disturbances from Superdarn, but we also have a connection to we're also seeing some connection of them to the large scale traveling ionospheric disturbances we're observing with the RBN PSK WhisperNet data. So that went really well. Now I am back for this week. I'm working on gearing up for next week because next week, this Saturday and Sunday, I head out to San Diego for the CEDAR conference, and I think I'm gonna have like 9 students there. So the 4 students from last week, plus Kung, plus Gerard Pacini and Alex Papadopoulos, and Rachel Bodeker is gonna be there, and Diego Sanchez, who's now a master's student at Scranton, he's going to be there as well. And then non-students going include Bill Engelke, who's on here, and Gareth Perry will be there, and Phil Erickson will be there, and Christina Collins will be there. And I think that's all the HamSCI people. So that's a really big contingent. And so I'm busy, working on posters and things like that, getting ready for that. And then we're trying to keep this project going as well. Also, I'm happy to say that Kukai, Dr. Kukai Hazumi, she is officially being onboarded and hired by the University of Scranton. So her visa got approved, and she went through the onboarding process at Scranton, and they gave her the offer letter and everything. So it looks like that's all going ahead. So and this week Anthony, Rachel, and I, we repaired the broken coax to my HF transmitting antenna today. So we got that done tonight too. So back to net.
Very, very good. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Okay, fine, Dave. Just a couple of small items. I got a new shack buddy here at this is Ricky
Oh,
Lou. She is about 3-month-old fox terrier,
wow.
and got her in Florida just about a week and a half ago. And she is all terrier and all puppy. She has a mouthful of X-Acto knives and has to learn how not to use them. I joke that playing with her sometimes is like playing patty cake with Edward Scissorhands, but that's I expected it. I mean, that's typical puppy behavior, especially terriers. So she will get over it. But anyway, she is about halfway through getting vaccinated, so she's not really allowed to meet anybody until she's 4 months. So she's got another 5 weeks of sort of house arrest. Anyway, on this project, as you recall, I was expecting that we would not have the personal space for the station network system up during HamFest because of the university simulated emergency test. And I was expecting we were going to have to re-upload stuff. Well, the website was down, but they left the HamSCI server up, running, and connected. So all the uploads went without a glitch. So there's no need for rerunning anything. So that was I mean, it wasn't going to be a big hassle. It was just going to be a Python program, but we don't have to do that now. So we did get all the data.
Very good.
So back to net.
Very good. Next on the list is Dave, KD0 EAG. Go ahead, Dave.
Hello. I've been doing a lot of CAD sorts of things. Sitting here at my little spot in my little nest of mess, while my house has been flooded by people all day, putting solarizing my house and also replacing a heat pump that has self-destructed from age, and or at least the compressors and stuff. And so it's been a kind of frantic day, but mostly just, kind of CAD, a little code, looking a bit at some of the the K9Q web code, just to see how that all works. I think I understand it now. And not a lot of other profound things. That's it for me.
Okay. Next on the list is Michael, AA8K. Michael, comments?
Oh, thanks. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is David, N1HAC. Go ahead, David.
Good evening, everyone. We're trying to play whack-a-mole with our AM Doppler radios right now. Maybe a heat problem or what. But we're keeping most of the system running most of the time, which I guess is par for the course for these things. Got a new project going that's going to include magnetometers and radios and GPS and all that. So I'll be hopefully making use of our technology within that. And I noticed that we just got a CME that hit, but the BZ was very much positive, so I don't have much hope for Aurora in the most immediate, but we'll see what how it pans out. I was amused by the fact that they thought that we had a big one coming at us from the X-class flare a couple days ago. Turned out it was going the other way. There's one headed towards us, but then there's one that was headed, it was a big one, so there must be a big sunspot on the other side ready to come around and shoot at us, but we'll see. And I have one last question. I wonder if anyone's been listening to WWV 25 megahertz. I have not heard it for a few days, and I hope it's just propagation and not that it's been off the air. Back to net.
Very good. Next on the list, let's see. Oh, Michael, AC0G. Go ahead, Michael.
Hello, everybody. Can you hear me?
Yes.
Just got back from Minnesota, picking up my second son from college. So now both boys are home and we are no longer as empty nesters, which we've been enjoying for a year, the academic year, I mean. So that'll be a summer adjustment. Otherwise, not a heck of a lot happening radio-wise here. I am curious whether Dartmouth is getting the data from the receiver that's here, because it looks like it's gathering some for the past 3 or 4 days.
Yes, we are.
Good. And the only remaining question is whether it's going to serve your purpose, because I guess my physical location is a little outside the area you were interested in, but
we will be determining that, but thank you for hosting it there.
Cool. And I'm building a TAD-1 to make more efficient use of GPS or of GPSDO signals here in the shack. Back in it.
Okay, next on the list, let's see. Oh, it'd be Franco, K4VZ. Go ahead, Franco.
Hey, good evening, everyone. I have actually more updates because I think last week I didn't think you guys had the call, so I skipped it. I don't like holidays. So in the last 3 weeks, I think since Hamvention, I've been working on this new DFC prototype. I was able to run that ADC, the 2208 up to 160 megahertz in single mode, or two of them at the same time, 100 megahertz. And then also running the DAC, but Justin Peng found a bug in the board, so I need to rewire a couple of wires on the prototype. I should be able to also have it transmit, use the DAC to send stuff out. I just write a simple signal generator to create something interesting to look at. And then on that, I've been helping Robinet with the SDR play back to my initial thing at KFS, and then maybe we can talk about that later. And then a couple of other things I've been helping. I don't know if you guys know Nick Holpatch is a guy that contributed, I think, for the medium wave recordings to the HamSCI. He had problems trying to figure out with SDR plays what kind of error he had when the clock wasn't right. So we did some math to figure out that part, and I think he's working on that. And that's about it for now. Maybe later I'll talk more. Back to you, Dave.
Okay, and next on the list is John Ackerman in 8. You are. Go ahead, John.
Hey, thanks, Dave. Since I'm not here very often, I'll try to keep the update short and not everything I've been doing the last bunch of months. But I think most important things are George and I are trying to get back working on GERT, the GPSDO. Glenn, with I think a lot of help from Franco, has come out with new firmware for his reference board that looks like it will be able to build on his original board, which is what we're emulating. So now that Hamvention and some of the TAPR product stuff is behind us, we're going to try to get back on that using the new code base, which will offer a lot more flexibility. So that project is still moving along, but slowly. And the other thing related to this group is I'm hoping that on Thursday we'll have a 6-meter whisper receiver running at our NHGA site. And that's the beginning of what I'm trying to build as a network of 6-meter stations around the Midwest. The AirSpy R2 seems to work quite well if you put a bit of a preamp in front of it. And we're going to get that running. And I'm also trying to get some transmitters seated. I have a couple of ideas for fairly inexpensive ways to get some 10 watt or so transmitters running. So that will be hopefully moving forward. And if anybody would like to put a 6-meter system up, let me know and I'll tell you what we have learned about it so far.
Okay. Is that it?
Mm-hmm. Yep.
Okay. Next on the list is Jim. Did I call on you yet?
Not
K4,
yet.
Go ahead.
Good evening, all. Well, not a whole lot happening right now. I had the pleasure of presenting some information on HamSCI to our local club here last Thursday. Seemed to be well received. I appreciate Nathaniel going over the slides for me. I did add a small section later. I don't remember whether I sent them to you or not, Nathaniel, of the disturbances in early May.
Oh, that's great.
But I was able to get that in. I'll shoot that to you when I get it, when I remember it. It's on my other computer. And other than that, just trying to deal with life here, not a whole lot in ham radio. Starting to get ready for leave on vacation in a couple of weeks. Back to net K4BSE.
Okay. Next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. Lately I've been thinking about with the various grant proposals that I've been involved in. I've been thinking about my VLEP system and how I could improve it. And after a reading about a uh, a VLF community member that has been contributing to the VLF community for many, many, many years. Since definitely before 2014. He has a VLF system installed at his location, and he recently updated it. And what he did was he used the Behringer UMC 404 HD. That's the Behringer USB audio interface. That's the 4-channel version, and the 2-channel version is used quite a bit in the VLF community for data acquisition. And I thought, well, maybe that's the route that I should go. It would make things simpler, easier, and allow sampling at 192 kilohertz. So I have come up with a new design that I just want to show quick for a minute here. And I was thinking that this design will be what I would pursue moving forward. So it involves instead of the backend processor, which is a box that has the Raspberry Pi and associated circuitry, I decided to kind of ditch the Pi and go with a Dell Wise 5070 thin client. The reason I decided to go with that thin client is that, well, we have some at work, and I noticed that they have an actual hardware serial port. And the hardware serial port is extremely useful because that's one of the few low latency ways to get a pulse per second signal into a computer. So I've decided to build a VLF system based on that, a Dell Wise 5070 thin client, the Behringer UMC 202 HD, that's the stereo or the 2-channel USB audio interface, and the circuitry that's inside the Raspberry Pi box. I would separate that and have 2 boxes. One is a VLF receiver interface box, which drives the VLF preamp and has the various isolation for power and signal output, which then is fed into the audio interface, and then the GPS interface box, which has a RS-232 serial with pulse per second, which is then connected to the serial port, and it also has a pulse per second output with associated circuitry for level changing the voltage level and pulse shaping if necessary, and that's fed into the other channel of the audio interface. And going with this, these Dell Wise 5070 thin clients, you could get them. They're not manufactured anymore, but they could be had for pretty cheap, around $50 a piece. They come with the built-in 16 gigabyte eMMC, and I wanted to use Debian Debian Linux with a very small embedded system. That'll be plenty for all of the VLF stuff, and either an internal NVMe drive or an external USB drive or thumb drive, and that would replace the VLF backend processor and this would have many benefits. And these thin clients, during idle, they run on like 5 watts of power. They're really nice. If there's some time later, I would like to discuss this with you, Nathaniel. I'll see what you think, how you feel about it. I also have a 3-channel version, block diagram. But that's all I have. Back to the net.
Okay. And next on the list is Majid. Go ahead, Majid.
Hey all. It's summer, so school is pretty quiet now. But I'm involved in the project with one of our faculties that I'm designing a blade for windmill. And this is going to be small for the labs, and this is going to be for slow speed. Right now, I'm working on SolidWorks to design these blades, and on future, we're going to have a motor that pitch all the blades in one time, all 3 of them at one time, to make him in a 0 angle. Basically, when sees the wind, is the speed as the wind is high, this could be a slow down and not harm the generator, basically. So we are in this process, and it's pretty new for me, and I'm enjoying it. Back to the net.
Okay. Next on the list is Phil, KA9Q. Go ahead, Phil.
Hi guys, not much to say today. I think I've got a cold or something, so I probably shouldn't talk too much, but I'll be listening. Go ahead.
Okay. And Rob, I'm going to skip over you for a minute, but I want to call on Tom McDermott. Go ahead.
Oh, good evening, Dave, and everyone in the group. Let's see, I've been trying to get KA9Q web back and running. I've not been successful. I've gotten GRRTPs working good on the latest poll, the latest KA9Q radio software. Web, for a while there, was dropping about once every 6 or 10 seconds. The display, spectrum display would black out and it would leave a black line in the waterfall. I went back to an older build, a very old build, and it started working. I went to the latest build and pulled it. And now instead of once every 6 seconds, the display is flashing uncontrollably. And I think I'm losing about half of the waterfall displays, and they're showing up as black lines on the spectrum. The audio is fine, however, which is unusual. So the audio from KA9Q web's working, but the display is just flashing uncontrollably. I've not been able to get a combination that works. I can get combinations that build but don't run, combinations that run but don't build. And so I've been going through all of those and not able to make forward progress. I'm on the latest of everything as of about a week and a half ago, and the display flashing in web is the only thing that I'm still currently hung on.
Tom, what are you running?
Tom,
what are you running KA9Q radio on? What's the platform?
On the server, I'm running it on a Core i5 11500. On the client, I'm running on a Core i7 3470.
Okay, that should be okay. But
Yeah,
take a look
yeah,
at
HTOP
radio and see what the FFT threads are using.
Yeah, I run HTOP. There's no thread over about 15 or 20%.
Oh, okay, all right. You know what I'm getting at, right? You've read that?
Yeah,
Okay.
I don't think there's any thread losses. The audio is working. So it's a display. It appears to be a display problem. One note, the NVIDIA graphics card I have on the i7 3400 is a 660, and NVIDIA dropped all support for that graphics card. Now, I'm on an older version. I'm on 2204, and it was current when that was built about 2 years ago. But it's possible I have a graphics problem, and I'm going to try and find some other graphics solution. I can't seem to isolate the problem to anything else, and so my guess is maybe graphics. That's just a wild guess right now. I've tried almost everything else I could think of. My GRRTP works fine, no display issues there. That's all working like it was before. I've also put together a initial draft of this requirements document we talked about last week on the call. And I'm titling it the extremely unimaginative HF 2024 HamSCI receiver system. And somebody else can come up with some much more clever name, but that's at least descriptive. It's hosted by Scranton. It's on one of their sites. And I tried that. You can actually edit the Word document on the web without having to install any tools on your client. So right now it's there. We may want to talk a little bit later about how we can collect contributions, go about the editing process, things like that. So anyway, that's been the week. Back to the group.
Okay. Nathaniel,
Yes.
since John is here and has a short time frame, I want to give you a chance to talk to John about the radio project. We still have Rob Robinette, but I do want to make room for you to be able to talk to John Ackerman.
That sounds great, John. So, and Dave, hi, John. So, first of all, I think we've kind of mentioned, or you probably were, John, that we're trying to redesign, a new, SDR. This is going to be inspired by the RX 888, but we want to have precision, frequency, and timing, capabilities. And perhaps the best thing to do is to bring up the requirements draft document that Tom wrote out and kind of go through it and discuss it. Does that make sense?
Yeah.
Okay. Tom, I do have it here. I can either share it on my screen or you can share it on your screen.
Yeah, why don't you go ahead, Nathaniel?
Okay, that sounds great. So, and so people share. Let's see. What I'm also going to do is apply, copy link. So I'm putting in the chat a link to the document. This is a read-only link, but that way anyone can just go and peruse it at their own speed. So if you miss something that we say or you want to look ahead or backwards, you can do that. So Tom, so thank you very much for putting this together. It looks really good. So okay, so HamSCI 2024 HF receiver and requirements document, version date May 28th, 2024. So Tom McDermott did the original issue. And so we have our introduction, scope, purpose, cost, goals, form factor, objective, power supply, RF module inputs and outputs, data engine interface, clock interfaces, antenna interface, RF module performance requirements, receiver noise figure, dynamic range, ADC clock jitter, clock phase noise, noise source and control, RF attenuator and control, filter module, interchannel crosstalk, and identification. Okay. So this all looks very good. Introduction scope. This document describes the requirements for a HamSCI year 2024 HF receiver system. The receiver system is comprised of an HF receiver with multiple channel A to D conversion, high accuracy clock and time injection filtering, a connection to a host computer, and other ancillary functions. These may be on one or multiple modules. Okay. That anyone have any comments on the scope? Okay. Purpose, the HamSCI 2024 receiver is a system initially to provide up to 4 synchronous receive channels from the antenna connector through the ADCs to a host interface. It receives radio frequency signals in the 100 kilohertz, 330 megahertz range, optionally filters and attenuates the signals, digitizes the signals with a low jitter clock, and transfers the digitized samples to the host computer. This may be done via USB, or perhaps a different interface. The main module might have one receiver in it, and additional channels might require additional modules. Alternatively, each module may be designed to accommodate multiple receivers. The unit provides for an integrated noise source that can be programmed to connect to each receiver to a broadband noise source of known amplitude in order to calibrate the receiver sensitivity and provide comparison to the estimated background noise level. The unit may use a single noise source for the received channels, but will require multiple relays, one per channel, to select the noise source. It also provides for programmable attenuators, antenna connectors, plug-in RF rejection filters, which may be on the module or may be external to the module. The noise signal is injected ahead of the attenuator and the filter. This provides the ability to capture test data that will allow determination of a filter and other characteristics being applied to the received RF signal. Any comments here? One question or comment. I know we've traditionally talked about 30 megahertz. Would it make sense to go up to 55 or 60 megahertz to cover the 6-meter band and get sporadic E? There seems to be a lot of interest in that. And if we do that, will that significantly change the cost? And is that a smart thing to do?
I would say it's a smart thing to do, and it's things like the 2208 already do that, are capable of that.
Yeah, the key, on the RX-888, of course, the power dissipation is dependent on the ADC clock rate, as we found out. But provided we address thermal issues properly, I don't think it should be that much of a problem.
Well, your problem is going to be if you want to have 4 receivers and then you want to sample, let's say, 60 times 220 megahertz. So how you going to send it over to USB, guys?
Yeah, we do have to work at the interface, but it would be very desirable.
Right. Later on, we'll propose USB 3.2 Gen 2 as the interface, which translated into normal speak is 10 gigabit USB.
Will that sounds like it will be sufficient.
Yeah, the problem
Likewise, you
then,
could
no
use
one knows
multiple interfaces. The whole trick, you haven't mentioned it here except at the very, maybe in the very beginning, but
if we
you
use
need to be able
multiple-
to have tight timing so that
there's a discussion on timing later on.
Right.
And if all the ADCs are on one module, it means one thing. If they're on different modules, then you have a different problem to solve. But if they're on different modules, you might have multiple USBs going. So there's trade-offs both ways. I tried not to specify the solution in this document, but rather the requirement.
Yeah, but the timing is very important in a number of ways. One is within the unit, but also you want tight timing so that you can do time of flight measurements and that you can do interferometry between different receivers.
Yeah, that is covered in
places.
the timing section of the document.
Very good.
One thing though is if we can get 6 meters without it hurting anything else, that's wonderful. But from the experience that we've had so far with the 6 meter work we've done, you pretty much want to have a different antenna for 6 than you do for the lower bands. And as a result, having the wide spectrum in one module may not be that useful if you need to combine antennas into it. So it might be better to have a module just for 6 meters. It could be a lower band with lower cost because it's going to get its own antenna feed. That's just a thought.
Yeah, so would it make sense if it can have up to four synchronous receiver channels? Are we doing modules here, Tom, or are we doing could you have 2 30 megahertz modules and 2 6-meter modules?
Yeah, it being a requirements document, it leaves that open right now.
Okay.
And with time, I'm hoping
the RX-888 type, it will do the high frequency. It's just a matter of what you clock it at. And if you don't need it, you clock it at a lower rate.
So Tom, you were saying?
Right. Right now, I'm trying to not dictate implementation
Okay.
in the
I'm just,
requirements document.
what I'm going to do is I'm going to leave this as an open question for now.
Oh, good,
And
good.
I will just say, and we can debate this more later. So I'll
Okay.
just say, possibly up to 60 megahertz to support 6 meters.
Okay.
And then we can debate this more later because it sounds
Sure.
like it's all right. So let's just go on. Cost goals. The cost of receiver system depends on the number of channels, filter, noise, clock, and other options. The receiver cost shall be less than to be determined. The cost depends on number of receive channels, clock precision, equip functionality, and perhaps other factors. I think I would like this to be my comment is I think it should be between $500 to $1,000.
Okay.
And the reason for that is the EDIS USRPs that do this sort of thing are about $3,000 to $4,000. So this will be significantly less than that. And it also seems like a price range that amateurs would be willing to potentially field.
Okay.
Does any ideas or discussion there?
Yeah, a couple of comments. Is gonna be all open source or not, or just a PCB, or just the software, or everything?
I'd hope it would be all open source.
So including the Gerbers?
Yes.
Are you ready for the Chinese to make a clone half of the price?
Well, I mean, honestly, well, I guess part of it depends on who's paying for this and how it's being paid for. So we're not, I mean, at this point, I'm not putting any NSF dollars into it anymore. So it's not really beholden to the NSF grant. There's some open question as to whether ARDC dollars are being put into it. And if ARDC dollars are being put into it, then ARDC generally has a mandate that things be open. How open those things are can probably be debated. But I think that, that could be maybe something more for the TAPR board to decide exactly what this.
Yeah, I think it really comes down to what's the financial risk. If we have to build 500 units and invest hundreds of thousands of dollars up front, we don't want that to be undercut. But if we can make batches of 25 without a lot of upfront investment, if somebody else can make it cheaper, that just makes them more available to the community.
Yeah.
So it's the balance of just making sure that we don't lose money while we have an upfront investment to deal with.
Yeah, I agree with that, and I want to do things that. So my main goals are to make this. I want to see this be affordable to amateurs. I want to see it be certainly open in terms of people developing for it and coming up with new modes. Regarding production, I think it makes sense to do things if TAPR's developing it, to do things to protect, TAPR's interests. And as I said, part of it, if only TAPR money is going into it, then I think TAPR really gets to decide exactly what this is. If ARDC money goes into it, I know they do have this open source mandate, and then I guess TAPR can discuss with ARDC exactly what the requirements are for that.
Yeah, I mean, we want to be as open source as we possibly can, and it's just a matter of the situation where you end up with a bunch of inventory that you can't sell because somebody's already undercut you on the first production run.
Yeah,
and there are several ways to deal with that minimize that problem.
And I think that all makes a lot of sense. So, yeah, so I guess, yeah.
No, the thing is, John, if you put four LTC 2208s, $100 each, it's $400 just for the ADCs. If the Chinese put the same thing for $15 each, they are $60, so they are $300 less than you. So that's something to consider. I mean,
Yeah, and I think again, it's sort of if other people can make it cheaper and it works as well, let them have at it, right? We want to get the radios out there. So our role is to get the ball started. And instead of if we do a first batch, say it's 100 units and it's a the $50,000 upfront cost. We just need to make sure that we can recover that from that first batch before the cloners have a chance to clone. And then after that, if we can do smaller production runs, as demand calls for, we can kind of deal with the risk of that piece by piece as it goes forward.
What I want to say, John, is the adoption I've seen is exponential negative in the price. So if you slice the price by $100, you get twice many people to buy it and to use it and to figure out things. Like if the RX-888 had costed $500, I don't think we would have had all this big success that we have now. If this thing is, it costs $100 less, then you get probably twice as many people try things. So I can use for radio astronomy. I don't even know, but that's the kind of thing that I think we should pursue. I mean, at least try to pursue.
So maybe that's another way to look at it too. Currently we have the RX 888 plus a Leo Bodner, and some additional parts from Paul Elliott that for about $500 gives you a solution that basically works for us. So
that's
we want
one channel.
That's
We're
one
talking-
channel. Yeah. So, but I think is this $500 to $1,000? Is this feasible? Can we do this for this?
Well, because you've talked about it, depending upon number of channels and all, yes.
Okay. So it could be
the basic single channel or maybe even double channel system. Maybe we can get it to $500 and then it goes up from there.
Yeah, I think that might be a good way to put it. So like,
base system, 500 to 1,000.
Right.
Yeah. Okay.
Base system is a good term.
Right. Edit comment. Base system, $500 to $1,000, and that can be what the base system is exactly, can be defined later. Okay. So form factor is to be decided. The system may be monolithic, modular, or something in between. The requirements are intended to apply to the whole system. And I think that makes sense. I'm guessing. Any comments on this one?
I think over time, we'll refine the requirements to become more of a functional specification. We may decide that certain pieces need to be integrated together and don't make sense to be modular, whereas other parts can be modular. And hopefully we'll get a little clarity over time with where the boundaries are.
Okay. So that sounds like it's probably going to end up being something in between, but will be defined more over time.
Yeah, if it's fully modular, the cost of all the SMA connectors will blow out the cost budget.
Right. And then it also makes the form factor more bulky and a lot of other things too, right?
Yeah, well, it dramatically impacts the reliability, I think.
Yeah. Okay. So
if you don't mind, could we jump to the clock related stuff? Because I've got about 15 minutes before I have to disappear.
Okay.
How about this? Clock
Okay.
down clock interfaces. The receiver system may have an interface to a high-performance clock system if it is external. The interfaces are 10 megahertz or other frequencies such as 27 megahertz clock. This is intended for use as a precision frequency reference from which the ADC clock or perhaps other signals are synthesized. And then 2, a PPS input. This is intended for high timing accuracy signal of 1 pulse per second to time mark the receiver digitized data. The receiver channels must be clocked by phase coherent ADC sample clocks. It is recommended that the multi-channel units use signals for the ADC clocks for the ADC converters that are referenceable to a single common clock in order to maintain tight phase coherence between the channels. If the ADC clocks between the channels were to vary with respect to each other, the downconverted baseband phase between them would wander, causing degradation or loss of the ability to use the two channels for receive polarization control. If the ADC is synthesized from a different reference frequency input, all of the multiple channels should be referenced to the same synthesized output. Otherwise, different synthesizers may have different initial phase offsets at each power up. This may require strapping to determine which unit provides a common ADC clock to the other units. The various modularity options will likely determine the exact ADC clock distribution method. So
Can't argue with any of that.
that's the clock interface section. Is there another clock?
One thing I will point out is that the capability of feeding it an external 10 or a 27 input is desirable because different house systems may feed a different clock. 27 is common for a lot of people, but a lot of us have 10 megahertz.
Also, if one of our major applications is doing Doppler measurements of 10 megahertz WWV, would it make sense to not have a 10 megahertz clock?
That is one reason that you might want to set a different input. You could even, given whatever functionality we have in the clock system, you could have an arbitrary input. But the ones that are common are that I've seen is 10, 24, or 27.
25 is also commonly used with the 5351 synthesizer, although nothing says that that's what we're going to use. But I agree that the flexibility is good, and the 10 megahertz WWV case is a great example.
Yeah, so one of the key decisions here is you could put, for example, a 4-to-1 clock distributor on every module, and then use it on the first module and set the other 3 modules as secondary. So the first module would provide the ADC clock to itself and the other 3 units. That's one implementation possibility. The other is to make all the clock and clock distribution external and just have a single input on each unit and rely on that external device to make sure all 4 receiver modules, for example, would get referenceable ADC clocks. So they're both are possibilities. My hope would be in going through the spec, we'll make a decision and then write down what we decided.
Great. So there are other clock sections here. So there's one on ADC clock jitter and clock phase noise. And so why don't we jump down to ADC?
You may be able to click on the page number.
The page.
I'm
trying to do that.
Okay. Well, it works in Word. So, okay.
Yeah, I'm on the online version of Word.
Okay.
Okay. ADC clock jitter. The ADC clock shall exhibit less than ±1 picosecond jitter peak. Note the jitter on the clock degrades the SNR of the ADC conversion. See figure below from a representative ADC specification, which graphs this effect. ADC clock jitter is determined by the clock. However, the receiver must be careful not to degrade the jitter. Here's our
Yeah, the what 1 picosecond could be challenging with something like the GERT in its
Mhm.
simplest form. It's not undoable, but that's be something to work for, whether we can do it for the cost.
Okay, yeah, if you look at the chart, you can see the impact to the SNR if it's a bit higher than that. And of course, it degrades the sensitivity at higher frequencies.
And it would also be relative to the frequency, Tom, wouldn't it?
Yeah, if you go down to the chart, you'll see, for example, the 1 picosecond line shows that at like 50 megahertz, you're talking an SNR degradation of about 4 or 5 dB. If the clock jitter is 2 picoseconds, it's going to degrade the SNR another 3 or so dB.
Mhm.
So it is an important parameter.
Yeah. And the kind of synthesizer chips we were looking at for the Tangerine were in the femtoseconds range.
Okay.
But the much cheaper GERT design
Yeah.
isn't as good. So we'll have to decide cost
Okay.
versus performance.
Right. And you see down at 30 megahertz or so, they all have, or 10 megahertz, it's somewhat less important. So we may make a cost trade-off there.
Yeah.
Again, options are helpful.
All right, clock phase noise. ADC clock input to the RF module shall meet the phase noise requirements in the clock module specification. Briefly, these are the clock and synthesizer phase noise shall be less than -60 dBc at 1 hertz offset, declining as 1/f to less than -120 dBc at 1 kilohertz offset.
Those seem to be reasonable numbers. Although again, Tom, where I always get confused when we start talking about ADCs and clocking is at what frequency are we measuring that? Because I'm never sure with ADC clocking, do you have the log phase noise decrease with frequency the same as it would be in an analog multiplier? But anyway, we just need to know the frequency, but I think the range is
Okay. It was intended to apply at the upper frequency limit 30 megahertz.
okay.
However, we need to clarify paragraph 4.4.
And I think, John, the short answer is yes. It would be similar to an analog multiplier.
Yeah. So the requirements are less stringent the lower frequency. If we want to include 6 meters, it gets harder. But the numbers are within range. I don't have any problems with them as a starting point.
Great. And then the phase noise specified at the ADC clock frequency of TBD megahertz. Typically the numerically controlled oscillator will be derived from the clock reference signal.
Yeah, again, that just gets back to how we define things. Yeah.
Okay.
Yeah.
We'll leave that item open and make a note.
Okay. It still says TBD there. So
Yeah.
I think that looks like everything regarding clocks in this document. Is that true?
I believe so.
Okay. Well, thank you. Now back to Ned, and I'll hang around for a bit longer.
Okay, great. How are we doing? Was the time stamping defined in the clock interfaces section, or is that in the data interface?
The clock interfaces defines a PPS input.
Right.
And nowhere in the requirements document does it say how it's utilized.
Okay. Is that something, because we do want that time, very accurate time stamping on the samples. Is that something that should go in this document?
Eventually, yes. The question is how to go about doing it in a cost-effective way.
Right.
And my guess is,
well, first, I think we can determine an accuracy figure that we're trying to hit, like sub 10 nanosecond or whatever.
Yeah.
And then we can figure out how to implement it.
Okay, when we did that on Tangerine, we initially said 50 nanoseconds accuracy on the PPS, including GPS storm events.
So let's see.
That's not in this document.
Now, yeah, but now the thing is that if we're trying to do coherent sampling between receivers, that would not be sufficient.
Well, yeah, the problem is during GPS storm events, right, you're going to get a lot of movement in that PPS time. And John and I think we both measured that, probably about a year and a half, 2 years ago on Tangerine, and we were getting right in the 50 nanosecond range, I believe.
Now, are you talking L1 only?
The receiver I used was L1 only.
Well,
Right.
and it's very important whether we're talking about absolute time sync across geographically distant stations or
Yeah.
time sync within the system.
Right. Well, that's what I'm bringing up.
Time sync within the system, 10 nanoseconds is fairly easy, with easy being a relative term if you use care, but 10 nanoseconds relative to UTC is at the point where it starts to get really, really expensive. So
Right.
there's a very substantial trade-off in.
Well, again, just as we were doing with Tangerine, having a multiple levels of timing accuracy would be useful. I mean, I think we also want to have a dual carrier capability on this for TEC measurements as well. So there's a reason to have a dual channel GPS receiver involved, both for the timing and for the science.
Yeah, nothing in the GERT design would rule out using a dual channel receiver. Please don't put easy in the document.
Is
achievable.
Achievable.
I'm just quoting you, John.
There you go. With the use of the proper statistics, almost anything can be done.
Is achievable, but this becomes prohibitively expensive for distributed.
No, it's not prohibitive. It's just more expensive.
Much more.
Consider that the National Time Laboratories are maintaining within a couple of nanoseconds of each other.
Right.
Yeah, getting better than 10, you're talking about temperature controlled antennas and a lot of other things. 10 is kind of the break point. Above that, it's doable at home. Below that is getting really, really serious.
Well, John, what is
John?
capable?
How close is the GPS to UTC? It's not. They're not the same, were they?
They are. It's a good point, Phil. They're within a few nanoseconds these days.
Okay.
And the time scale is the same. Leap segments change.
Yeah, the USNO and or NIST publish the offsets between GPS and NIST after the fact, but it's small numbers, but you have so many variables in synchronization via GPS, even with dual frequency, that it just becomes very difficult.
John, what is considered the spec using dual frequency?
It's really, dual frequency reduces the noise. It doesn't really change the long-term accuracy.
I thought it
Dual
reduces
frequency is
the
just letting you compensate for
ionospheric error.
momentary ionospheric, but there's a new generation I haven't looked at yet, but the expensive U-Blocks ZF9 receivers have 8 nanoseconds of jitter second to second is the spec.
John, I thought the purpose of dual frequency was to better model that ionospheric error, wasn't it?
Yeah,
Rather than using built-in simple models.
it does. So over time you get less noise. I mean, moment to moment you get less noise, but over time it averages. It's not
Oh,
going to
sure,
make a
sure.
difference over
Yeah.
thousands of seconds.
Sure.
Yeah, John, does RTK improve that for distributed receivers?
That's a really good question, and there are some time-oriented RTK systems out there. The only ones that I've seen are very expensive to subscribe to.
Okay.
Whether you can do it yourself, I don't know. It's a good question, though.
What are these septentrino modules or whatever they call them, septentrio, that even SparkFun is now selling, but and the classic, apparently the standard for TEC stuff for a long time was a $10,000 rig sold by that company. But they actually use sometimes the U-Blocks receivers in them, but it's part of a module. Maybe it's just for RTK. I don't know. But
Well, Septentrio has their own very fancy stuff, and their cheapest evaluation board used to be about $800, and it's now about $1,200 the last time anybody looked. And it has lots of nifty features, but its absolute performance isn't that much better than the U-Blocks. And the U-Blocks, and any receiver that's dual frequency that gives you raw carrier phase can do TEC.
yeah, but it has to be frequency.
But you just have to have the data available out of the receiver. How good it is will vary, but I think when you go from $1,000 to $10,000, you don't necessarily gain 10 dB of performance.
Well, that was a standard in the not so distant past.
But it still is.
Selling a module, I don't know exactly what it does. I think in the range you're talking about, or maybe even a little less, even on SparkFun. And Ardu Simple selling them. And I'm not sure whether they have them on, on the Latvian site or not, but
yeah, I think it brings up the general question. A very high performance is achievable at very high cost.
Yeah.
And it sounds like, it's a case where having a PPS input and a frequency input to the receiver and leaving the exact clock specification elsewhere might be an appropriate thing to do.
Yeah, it's a good point. And fortunately, the way GERT is designed, we can use anything from a $6 to $1,000 GPS module in it. It's just what you plug in. I don't know that the performance will improve again as you increase the cost. You're not going to improve the performance equivalently, but if you need more features, we can do that. But
yeah, obviously the highest, it's going to be challenging to meet a $500 goal with the highest performance clock requirements in a single channel.
Yeah,
and
but
so
I'm still hoping that the GERT product, which may not meet your jitter requirements exactly, but isn't orders of magnitude off, is going to be in the $100 to $125 range.
Okay.
So, we can get a basic GPSDO for a cost that I think fits into with that desired budget.
Okay, so what we may want to do is kind of cooperate on the GERT spec and the clock spec here. And say, the $125 version can do this, and that will be the performance. And if you want more performance, substitute it with some more expensive clock system.
Yeah.
Okay. Okay.
I think one of the things, I think one requirement that doesn't necessarily have a number attached to it is to require time synchronous time stamping of samples from all receive channels. And can we allow multiple receiver units to be connected together to give n sample synchronous
Marking.
channels.
Yeah, but we defined that earlier for the clock, but not for the PPS.
Yeah.
And, you know, we can put in the same verbiage that we might, use a similar approach of having one module be able to distribute time marks to the other three, or all that may be external. Let me think about how to word all that.
And since we're getting away from an FPGA-based design, I don't know, and other people on this call know much, much better than I do, whether it's feasible to timestamp individual samples through the architecture we're talking about. Maybe saying that we can recover timestamping would give us more leeway if it's something that's not actually, you know, part of every single packet.
Right. The spec right now doesn't say how to do the marking. And that was intentional. Because I think folks have some ideas they want to test. We use the FPGA in Tangerine, but you know, Jonathan's used an analog pulse injection in the RF stream to or the ADC stream. So there may be a way to do that. When you start injecting analog signals, then you need to have relays and calibration and other things you may need to do. And so there's so it's undefined right now.
My feeling is that injecting an analog timing signal would not have the precision.
Oh, you run up against the fact that you'd like to have a pulse that's got a zero rise time, which means infinite bandwidth, which doesn't fit in 30 megahertz. Plus, you've got to receive through that as well. So,
right.
You know,
So if you have a
great
band
idea, but it's
I mean, if you're thinking putting in an audio pulse at some arbitrary frequency, the bandwidth is not there to get an accurate timestamp time. But there are schemes that you could do to timestamp your packets. You don't have to have every sample have a timestamp attached to it, as some formats do. But you know, if you had, if you knew when you started the packet in some way, which could even be like a memory location algorithm, and packets can be arbitrarily long. You can have a 1/10 of a second packet, so you don't have a lot of overhead for timestamping.
Right. The other possibility, since we might use, for example, the Cypress controller, the new one, is to go put the PPS into a digital input on that Cypress controller.
Right.
So I think that's going to take some clever folks who are involved in implementation to maybe help us sort that out.
By the way, I had raised the question for 25 megahertz. I just heard our HamSCI modulation on 25. It's a good test signal.
One thing I'm not clear on, and perhaps I should be, but I'm not. How do we know what time stamping accuracy is really required? Because doesn't that corresponds back to like distance, right?
Yeah, it's a nanosecond a foot.
Right. Well, distance and ability to direction find.
Right. Also, polarization discrimination.
Right. Now, between there's will be a difference between channels within the receiver, and you can achieve certainly with sub-nanosecond between all channels within the receiver. The question is, can you get what is the level of synchronization that you can get that would allow you to use receivers at multiple locations and
that's what we were,
get useful interferometry.
yeah, and that's
Yeah,
what we were
there's-
talking about earlier, that 10 nanoseconds is where it gets really, really hard.
Right.
So,
So we can certainly start there, get it to that, and see what we can do with it.
right, one of the key things to do there is the ability to characterize the antennas, the feed lines, the filters, relays, interconnection connectors, because all of those are going to affect the results. And so there's text in another paragraph of this document that says that the receiver should be able to output control signals to relays to allow calibration of timing from all the antennas.
Yeah. You also need to do that for the GPS system, because the SAW filter in a GPS antenna can have 10 or 20 nanoseconds of delay.
Yeah,
Yes.
but we routinely have to measure the delay on cable to the antenna and all of that, all the cables,
And that's the
all
stuff where
the
you get the,
group delays that through filters. You have
Yeah,
to
well, you-
characterize that, but generally, once you characterize it, they will stay stable.
yes.
Right, so the key impact, I think, is temperature on feed lines.
Right.
And more or less, that's the reason you would want relays, is to inject test signals, capture them through the interconnect network. And so that may mean that the antenna has to have a relay in it, and you have to be able to send a control signal to the antenna. There's a number of options there. But if you're going to try to achieve 10 nanoseconds in the system, you're going to have to calibrate out your feed lines.
Yeah, and including the GPS feed
Yeah.
lines.
Right. So let me add a note, calibrate out GPS feed lines.
Yeah, from a cost perspective, the absolute time synchronization accuracy, against UTC is probably the single biggest cost driver in the system from a clock perspective. The tighter that has to be, the more expensive it's going to be, and the more difficult it's going to be for the user to set up.
Right. And so, my feeling is we need a way to hit the $500 cost target by downgrading whatever we have to downgrade in the clock system to get there. And then provide an option to do better for more expensive
I wouldn't
cases.
I think it would be reasonable to specify something of reasonable cost
Mhm.
as the base system, but have the capability of inputting, shall we say, a lab standard PPS and reference frequency,
Mhm.
and have it be able to synchronize to that with reasonable accuracy.
Okay.
If we use the descendant of the GERT design, that will accept an external 10 megahertz, although that could be any arbitrary frequency input rather than GPS. So if you already have a source, you could use that, and you'll actually get quite a bit better performance.
And likewise, you could, for the PPS, you can have an arbitrarily accurate PPS that you're generating separately.
Mhm.
That would be nice to have it, one of the U blocks, like the 9, be able to be put in and get it there.
Yeah, it will be.
Let's see what we can achieve.
Okay.
But for those of you who've seen the earlier stuff, a year or so ago, I was designing a GPS breakout board that had plug-in modules, and we had footprints for the U-blocks, 3 different model U-blocks footprints. That's carrying forward. So we'll be able to plug basically any GPS module we want, we can make a daughter board for and plug into the system. And the cheapest one is a $6 Chinese which is what we've been working with for GERT so far, but we could go up to the U-Blocks, F9 or F10 if we wanted to.
Mm-hmm.
Okay.
That sounds great.
Yeah, I think that's good. Okay.
And with that, my eyeballs are telling me it's time to leave, so hopefully we've
think
got that
yeah.
part covered.
I think it might be kind of my time to go too. I think we should probably continue this discussion at a future telecon.
Okay. I will get in there and mark up the document.
Okay.
And then we'll pick a different week sometime in the future to make the next review of the edits.
That's
If anyone has contributions, please send them to me and I will get them into this document.
that sounds great. Dave KV0S, are you still there? I see his.
I doubt it.
Yeah, I see his name still there, but he's not there. So I'm going to be in San Diego next week for the CEDAR conference. So I guess the question is, do we want to have a telecon next week? I won't be on the telecon. You can still have a telecon if you want, or we can just wait another week to have it.
We usually find enough other stuff to talk about that's not part of the specification thing.
That sounds perfect. So
By the way, we haven't
Yeah.
heard from Rob yet.
He's wandering around.
I am wandering around. I've been out on a trip and just got back home. So I don't have I want to thank, can you guys hear me?
Mm-hmm.
Yes.
Okay, I just wanted to thank Franco and Phil for their efforts last week to help me put together a test, which I had wanted to do for years, and I think might be have some relevance to others. I, with their help, was able to put together the system out of KFS. So I have 4 receivers, SDRs, receiving the same RF from a passive splitter, a 888, a Kiwi, a AirSpy, and an SDR Play. And all of them are being processed by K9Q and being posted up with different call signs to WhisperNet. And in summary, and thanks to Dave Larson, I don't know that he's here, but he lent me his AirSpy HF Plus, which I've been told is this marvelous and so much better than the Kiwi or 888 receiver. In brief, the conclusions are there's hardly any difference among them. Same number of spots. The SDRs are the SNRs reports are almost identical. I mean, we're talking about 0.1% differences across 13,000 spots in terms of number of spots detected and the SNR differences. The SDR Play is worse, perhaps. I haven't, I'm just by inspection, looked like the SDR Play is maybe a dB or worse SNRs, and as a result, fewer spots out of the 13,000 on 24 hours on 20 meters. So on 20 meters, there's almost no difference between these designs. And I would expect more difference if I go to 10 meters, where the noise figure is of the Discovery ought to be more significant. So anyway, it took a lot of work from Franco and Phil, and I wanted to thank them for doing that.
Which receivers were you comparing, Rob?
I'm sorry?
Which receivers were you comparing?
The 888,
Mm-hmm.
Kiwi SDR,
Mm-hmm.
AirSpy Discovery HF Plus, and an SDR Play RP1A.
Okay.
So the RF that's given to them is conditioned. I mean, I do. It has a LNA ahead of them, and I want to fill Paul Elliott's shelving filters to reduce the overloads introduced by the LNA. But given that, actually the best of them is the 888. Surprising to me, I was very much surprised. I had expected the Discovery would do a little bit better.
Do you know what the other, what Kiwi or AirSpy have for converters?
The Kiwi uses it's a direct conversion and uses the LM2208, just like the clocked at 66.672 megahertz. I don't know what's inside the the SDR Play.
The SDR
Not
Play
only
has a Myrix chipset. The tuner is an MSI 001 and the ADC USB is an MSI 2500. But they are proprietary, so it's very hard to find the data sheets and everything and anything about those.
Yeah, and I know the SDR Play's got a 14-bit converter in it.
Yeah,
in the chipset.
We ran it at 5.7 megs, where it's still 14-bit. But if you go above that, it becomes lower.
Well, that's true.
So, and then the HF Plus, this AirSpy again has a. I don't know that they have Sigma Delta converters. They have a block diagram that doesn't mean a lot to me. Hopefully, I'm sure those of you more knowledgeable in signal processing would understand its differences. They, of course, they make tremendous claims for the Discovery Plus's superiority to other designs. In our application, whisper reception, I don't see that it offers any significant, and it comes at a real cost. It's a very narrow band. It's a 700 kilohertz sample bandwidth device. So you're really not comparing in terms of price performance comparison. It's it comes out last of them all. We can at least get 3 bands, ham bands, out of the SDR Play. You can only do 1 band out of the AirSpy. So for our application, my tests say by the 888. And I used Paul's little conversion kit, which is soon going to be on TAPR's site, I believe, available from TAPR. It's marvelously easy. I did a conversion in 15 minutes. I converted 2 888s, and they just came right up. I plugged in my Bogner. I went out to KPH and put up 2 888s there, driven by a dual output Bogner, and it just came right up. There's the whole thing is completely stable. It works extremely well. So so the 888 and with Paul's conversion kit, when connected to a reasonably powerful host, I think now we have a pretty stable system, and Phil software also is very stable and easily communicates and recovers from errors and does a lot of the other good things associated with a deployable piece of software. So I'm pretty happy with it's taken us a year to get here, but I do think that we have a very stable hardware and software environment at this stage. I mean, you guys are designing the next stage, and there's always better receiver designs, but for whisper reception right now, I think and for grape reception, I think that the 888 is working marvelously well. So that's my major report. We also had a conversation with, I guess, let's see, this was afterwards, a WWV working group, Christina's group. I participated last Tuesday, and both sites, Fort Collins and Hawaii, are both, maybe I'm being excessive, but they seemed eager, certainly interested and welcoming of deploying a whisper sound at each of them. So I have one here that I'm hoping to put together. There is one other element that I don't know who's left on the call. I'm still on my cell phone, so I don't know who's here. But we do have a whisper sound that's on its way to Ellesmere Island this summer in July, and I would like to send a 888 and a B-Link along. We have Pierre take those up and upgrade those. The Kiwis are marvelous, but they're not as good as the 888. One 888 definitely trumps a pair of Kiwis. And so if there's anything else, magnetometer and ELF reception system, now's the time to start planning it and getting out to Pierre and see if, and so I'm thinking I might organize a call. I'm going to be traveling starting next Monday, so I don't know, I'll be in Europe, so it'll be hard for me to organize it. But if you guys want to have a full-on a personal weather station installation up at Ellesmere, we should be talking about it with Pierre right now, this week. So I think he's open to doing all that, and I don't think any of it is particularly hard. But it takes time, and he has to get stuff that he can carry with him when he travels up there.
Right. Oh, by the way, that reminds me, Nathaniel, I wanted to make sure that you knew that we actually have dual hemisphere systems as well.
Oh, great.
That's one thing Jim has been doing. We have the receiver at South Pole, and then we have a conjugate on Baffin Island.
That's great.
Rob?
And I think Gareth knows about that, but might need to be reminded.
That sounds really good.
We had to
Okay.
work on your antenna, Nathaniel, at some point.
Yes, I know. And unfortunately, I have other things that are more pressing at the moment.
I
than, like, trying to-
understand, and so do I. So it's probably
So I have your emails and I have not forgotten about them, but unfortunately, I've just tried to. There's a lot of other things I'm trying to keep going too. So
yeah, well, getting a receive site together is not a one-day project.
no.
Yeah.
So that will be.
I think
that will be in the future. I'm going to sign off for now, but
Nathaniel, you say you're going to be in San Diego. Remember, I live here.
yes, so that's right. Are you let's see. I think a really good day for you to come visit us would potentially be Wednesday. And Jesse Alexander is going to be giving the invited DEI talk on Wednesday morning.
Oh, okay.
And then a lot of my students have posters Wednesday afternoon. So if you were to pick a single day, I would say Wednesday would be the day to come.
Okay. All right.
Um,
Christine also said that she was going to be here next week with I forget who, and wanted to do lunch or dinner, but she hasn't gotten back to me at which day yet.
It would be with the same group. So
Yeah,
we're all in the same conference. So I mean, you can certainly. So what I can do, Cedar. Okay, they should have the agenda posted. Now I'm putting it in the chat here, Phil.
Okay.
And so you can read you can see the agenda yourself. You can, let's see. And then they have registration for scientists. So last year I was able to get some of the citizen scientists in at the cost of a student. If registration cost is an issue for you, talk to me and I can cover it with a grant or something like that.
And what is the registration? I don't know anything about this conference.
It's, let's see. Well, for a regular attendee, I don't know what the cost I have to kind of fill in all this. I don't even know what the costs are.
Yeah, is virtual the same as in person, or is that separate or less?
I think virtual might be less, but you also it's nowhere near as good.
Yeah, well,
I just want to come
Deadlines.
basically
I'm not getting there in person, that's for sure.
go
Yeah.
to lunch or dinner with you guys, really.
Yeah, and that won't cost anything. But if
No,
you want to,
no.
if there is something you want to see, like come to the poster session or hear Jesse Alexander's talk,
Yeah.
just let me know what you want to see, and I can talk to the committee and I can explain your situation, and we can probably just get you in, and it
Okay.
probably
Yeah,
won't
I
be a.
haven't talked to Jesse, but if he's around, I'd love to have lunch or dinner with him too.
Yeah, he's gonna be there, I think, from like Tuesday night through Friday.
All right. Well, just let him know, or I'm not sure I have his email.
Yeah,
Maybe
I
we'll all go
can.
to dinner.
Yeah, I would say probably we should probably do like Wednesday night dinner would be good.
What can yeah, Wednesday night dinner
Alexander,
is clear for me
yeah,
right now. Anyway.
Karn, I'll add Christina here
Yeah.
too,
Yeah, I
and
don't
then
think
we might
I'm not sure. I may look to see if she got back to me.
dinner at Cedar. Hi, Jesse and Christina, Phil KA9Q and I were talking about getting together for
Who's this to?
dinner. To you, Jesse, and Christina.
Christina. Okay, Christina was saying the 11th or 12th. What now sounds like the 12th would be the day to go.
Yeah, I know I'm busy for dinner on the 11th.
Okay, where is this thing being held? Let's see.
It's at the Hyatt, the Wyndham.
Is it like near the airport?
Yeah, near the airport, right across from the
Okay.
Maritime Museum.
Oh, okay. Yeah, there's a bunch of good restaurants nearby.
Yeah.
I'm
Phil and
local,
I
so
were,
I to know all the good restaurants.
we're talking about getting together for dinner.
But if I do
Wednesday.
that, I will have to know how many because I'm going to make a
Mm.
reservation if I know this
That sounds good.
and a time when you guys are all available.
Yeah. What do you think? 7:30 DE. Nathaniel.
Okay, you're including Christina in this email.
Yes.
All
Should
right,
talk about
Christina
if
and
we want to
Lewis,
invite any
and
others.
oh, and Ben, she mentioned Ben KB3 VSC,
etc.
Yeah, okay.
All right. Well, I'm leaving this as an open kind of discussion.
Okay.
Dinner next Wednesday evening.
All right. I'll just pencil in Wednesday evening
Diego.
on my calendar and then wait for you guys to tell me how many and exactly when.
Yeah.
By the way, Nathaniel, virtual is free.
Yes, but it's nowhere near as good as in person.
Well, but if you can't get there.
That's true. But no, Phil, really, if there's look at the agenda and if there's something you would like
All
to
right.
see, let me know and I'm pretty sure I'm on the steering committee. I'm pretty sure I can arrange to,
Well, to tell you the truth, Nathaniel, I've discovered through my career that the best thing about going to a conference is not anything formal. It's going to dinner with everybody.
Oh, absolutely.
It's amazing how many new
Yeah.
ideas get created over
Yeah.
dinners and lunches,
But the poster session's really good too. And like the poster
yeah.
session, the poster session, it's a kind of like at the HamSCI workshop, but even bigger. It's a whole room full of students with posters up and everyone's walking around.
That's true. Yeah, that's true. They're informal. You go around, you talk to people. That's true. Yeah.
Yeah, that's a really nice thing to go to.
All right. When is that open?
That's Wednesday afternoon.
Wednesday afternoon. Oh, all right. Well, then it sounds like just do everything Wednesday. Sounds good.
Yeah, and that's what I'm saying. If you came to Jesse, you probably would enjoy hearing Jesse's plenary talk in the morning, because I got the steering committee to invite him, or they invited him based on my recommendation. So his plenary talk, I think, is going to be really good. And then if you're able to, you can skip the oral session, like the other oral sessions. But I
Yeah.
think you'd really enjoy the poster session. And then we go to dinner
Okay.
right after the poster session.
Okay, I'll basically just pencil in Wednesday then. All right, sounds
Yeah.
good.
So I'll work on, I'll try to talk to the steering committee and see if we can get you in for free, or we'll work it out. Don't worry.
All right, no big deal.
Yeah. But I think you'll really enjoy going to those.
Yeah. All right, sounds good.
Great.
And you got to go. So
Yes,
good.
because I'm gonna look at setting up some more code for my students to use for their poster for next week. So
all right, see ya.
all right. Thanks everyone. Have a great night.
Good night.
Number 3.
All right.
7-3.
Phil, do you have a minute to talk?
Yeah, if I can, I got some